We're looking at a right triangle graphed on a coordinate plane, and the goal in this lesson is to find the length of the blue segment, which is the hypotenuse of this right triangle. Well, we can look at our coordinate plane and figure out the coordinates of the vertices of our triangle, and they're shown here. And then it doesn't take long to count the lengths of the legs of the right triangle, the horizontal red segment and the vertical red segment. The horizontal one is 11 take away 5, or 6 units long, and the vertical is 14 take away 6, or 8 units long. So the legs of this right triangle are 6 and 8. And most of you probably have already seen this formula, the Pythagorean theorem. A squared plus B squared equals C squared, where A and B represent the lengths of the legs, which we know, and C represents the length of the hypotenuse, which we don't know. So we plug in the 6 and the 8 that we do know. We square them to get 36 and 64. Add those two to get 100. And this is one we can do in our head. The square root of 100 is 10. And so the length of the hypotenuse of this triangle is 10. Many of you recognize this as a very commonly used right triangle called the 6, 8, 10 right triangle. And because they come out even, the 6, the 8, and the 10 form a Pythagorean triple. Well, let's add a step to the computations we just did, because to get the 6, we did 11 minus 5, and to get the 8, we did 14 minus 6. And now we have all of our computations written out nicely on a frame. Well, let's look at it one more time and write it as a single expression. We did 11 minus 5. We got a difference. We squared that. We did 14 minus 6. We got a difference. We squared that. We added the two differences, and then we took the square root of the sum. And this is the way to write that expression, is all one expression. And with order of operations, you would do the parentheses first, which is find the differences, do the exponents second, square the differences, and because the radical or the square root symbol goes all the way across the whole thing, known as a vinculum, we would then add the two differences and take the square root of the sum. As shown here, here are all the steps, and we still get 10 as our simplified answer for the expression at the top. Well, let's plug in variables that could be used for any pair of points that could be endpoints of a segment. And we'll call the ordered pair for one endpoint x sub 1, comma y sub 1, and the other ordered pair could be x sub 2, comma y sub 2. Plug them in as shown from our first example, and instead of 11 take away 5, we get x sub 2 minus x sub 1. Instead of 14 take away 6, we get y sub 2 minus y sub 1. But because we have all those variables there, we can't simplify it anymore, and we'll stop there. But that's going to be called the distance formula, and it can be used when you're given coordinates of any 2 points. And here's the distance formula written out. So let's do an example. Our two new pairs of points are 12, negative 4, and negative 3, 6. We line up our subscripted variables so we can substitute them into the formula as shown. And now we do the arithmetic. 3 take away negative 12 is negative 15, and 6 take away negative 4, of course, is the same as 6 plus 4, which is 10. And then we get 225 and 100. Add them together, we get 325. We need to take the square root of that. We need another frame for that. So we'll start with the square root of 325. And if you've ever worked with simple radical form, you would realize that 325 is 25 times 13, and the square root of 25 is 5. So you can write 5 root 13, which is called simple radical form. If you haven't worked with simple radical form yet, you could stop at the square root of 325, or perhaps you could type it into a calculator and round it off. I rounded to the nearest hundredth, 18.03. Here's another example. Our two pairs are 20 and 15, and our other pair is negative 12 and 6. We write in our subscript so that we can substitute into the formula, and here it is. Negative 12 take away 20 is negative 32, and negative 6 take away 15 is negative 21. We square both of those differences, and we get 1,024 plus 441, and we get this number as the sum 1,465 We need a little more room, but turns out we really didn't need much more room because we can't take 1,465 into any more simple radical form that it already is. So we either leave it like that or round it off to some agreed on place. I picked the hundredths place again. So our two possible ways to express this distance are the square root of 1,465 or the approximate value of 38.28. In this lesson, we looked at the distance formula. You find the differences of the x-coordinates and the y-coordinates, square those differences, add the results, and then take the square root of the sum of the differences. And that is the distance formula for any two pairs of points that can be written on a coordinate plane.